All right, welcome back. Let's get into it. Okay, so we got 2.5 today. Talk more about proofs. And I know this says 2.3. Ignore that. It's really 2.5. Let's say 2.5 on yours. At least it should. So you need a note sheet. And for your note sheet, we're going to be going through all the properties that we're going to use for proofs. We've covered most of them, actually, but there's some new ones that have to do with geometry. So let's look here. All right, so these first ones, we've covered most of them. I'm just going to quickly recap. Addition property, add to both sides. Reflexive, it's equal to itself. Substitution, you replace something. Subtraction, we subtract from both sides. Symmetric, you switch the order. You combine like terms, put two common terms together. We got multiplication. Transitive. Transitive, I will more likely than not use substitution, because in most cases they are identical. There's some situations where you need a distinction, but for all the situations we're going to talk about, substitution covers our bases. So I'm going to use that instead for most cases. Simplification, remember that is where it's your cover-all term for like adding, subtracting, multiplying, dividing, any operation. Division property, divide, and distributive property, you distribute in the parentheses. Okay, so this is our first new one. All right angles are congruent. So what that means is if you have two right angles, you can just state that they're congruent in your proof. And we'll get into some examples so you can see when you use that. Angle addition postulate. Okay, so I'm going to need to do an example of this one to show you what this means. We have mentioned this, but it's a bit different when you use it in a proof. So let's say we have an angle here. And let's say I have something like this. Okay, one angle they don't need to be the same. We can have different sized angles, that's fine. So let's call this A, B, C, and D. All right, so what we can say with the angle addition postulate, and maybe I'll title this the angle addition postulate so that it's a little bit more clear here, is we can say, there we go, angle addition postulate, addition postulate. We can say that these two smaller angles have to equal the bigger one, which is pretty obvious, but it's not obvious to use it in a proof always when you need to use it. Okay, so we can say this. We can say that the measure of angle ABD, the big angle, equals the measure of angle small one, ABC, plus the measure of angle CBD. All right, so we're just saying the two smaller ones added together make the big angle. Pretty straightforward. That's the angle addition postulate. All right, next one, vertical angles are congruent. Okay, if we have two vertical angles, right, we can just quickly drop this one here. 1 and 2 are vertical angles. We can say that angle 1 is congruent to angle 2. All right, that will come up a lot. That's the most common one. Put a star, circle it, put a heart by it. That is the number one we're going to use for geometry proofs. Segment addition postulate, very similar to the angle addition postulate. But now we're going to do the same thing with segments. So we got segment addition postulate. I just need to abbreviate it so it'll fit here. For the segment addition postulate, we are going to have a segment, and there's going to be some point on it. It does not need to be the middle. Okay, but what we're going to say is we're going to say that this part plus this part equals the whole segment AC. So we'd say that AC equals AB plus BC. There you go. That's segment addition postulate. And that one will come up occasionally as well. All right, so now we get into these definition of. So pretty much every other situation, every other definition geometry come with, you're going to say definition of, and a really common one is midpoint or bisector. That is a really, really common. So let's look at a midpoint example here so I can show you what I mean. So if I said definition of midpoint, so if I said definition of midpoint, that means that both sides are going to be the same, right? And abbreviate that again. So definition of midpoint, if I have this here, and let's say I have a point M in the middle, I'm going to This is A and this is B. Well, if this is the midpoint, then I could say that AM is congruent to MB. Or you could also say that lengths are equal, same difference, okay? Because that's the midpoint, that means I can say they're congruent. Another one, let me look which one I'm missing here. Oh, and also, this also applies for bisector as well. If you have a bisector, you can also say both sides are congruent. It looks pretty much identical. The other one is supplementary and complementary, so I'll just show you supplementary. And I'm kind of running out of room here, but I'll try to not take up the whole page here. Definition of supplementary. So definition of supplementary, so we're kind of filling in the margin here because there's kind of a lot you need to see, and not enough room quite on this page to show it. Okay, so if you have supplementary, then if I have two angles here, so let's say if angle 1 and angle 2 are supplementary, then what we can say are supplementary, then we can say that the measure of angle 1 plus the measure of angle 2, what does supplementary mean? Well, it means I have to add to 180 degrees, okay? So maybe they'll give you a picture, maybe they'll just state it, but either way, it's 180 degrees. And is there anything else I should mention from these? It's kind of a lot. There is one last thing, okay? And the last thing is, I'm going to try to segment this off so it's not too confusing here. The last thing that I want to point out to you is definition of congruent. And oftentimes I consider this an optional step, but it does sort of tie together the proofs that we're going to do so that you can get the answer you want, right? Because sometimes you're close, but you don't know how to get to that final step. So definition of congruent means this, okay? If I had segment AB is congruent to segment BC, right? But I instead need to say that the numbers or the lengths, like centimeters, inches, are equal. I can go from this to AB equals BC. And here's the key thing. I can go both directions, right? I can go from congruent to equals, and I can go from equals to congruent. Okay, so anytime your answer isn't looking exactly like what you're trying to prove, you're going to do definition of congruence, sort of kind of like a final step oftentimes to finish it off. All right, kind of a lot to start this off with, but we have to set the stage because there is quite a bit that goes into geometric proofs. All right, not gonna lie to you, the first couple are a bit rough for people. Takes a while to get used to it. All right, so let's start with an algebra proof to kind of soften the blow here. So negative 100 minus 4x minus 2 equals negative 94. And our reason is, our starting rate is always the same. It's because it's our given. All right, it's our given, and we're trying to prove that x equals negative 1. So we're just going to solve this, and we're going to state the reason each step of the way. There are many different ways to do this. Your work may not look the same as mine. So go ahead and try this, see how it goes, and I'll do it as well. If I were doing this, I'd get rid of this negative 100 first. So I'd add 100 to both sides. So it'd be negative 4x minus 2 in parentheses equals, and add 100, so it'd be 6. That would be my addition property. And I do abbreviate this quite a bit. As long as you can tell what I'm saying, or I can tell what you're saying, it's totally fine. Now I want to make this negative inside the parentheses. I'm going to distribute it. Negative 4x plus 2 equals 6. And that's my distributive property. And then we have, I want to get rid of the 2. So negative 4x equals 4. That would be the subtraction property. Make sure you actually spell this one out. So I don't think you're saying substitution. Oftentimes it's hard to tell what people are saying if they abbreviate everything, especially subtraction. And then we divide by negative 4, we get x equals negative 1. That's the division property. Very good. All right, so that's what the proofs we've been talking about so far. Now let's look at some other proofs here. And that's what we're trying to prove, right? X equals -1. Okay, so here's our first geometry proof. Okay, so our givens and our proof look similar, but the way we get there is very different. So let's first label this in our picture of givens, okay? And I strongly recommend making a game plan. 1 is congruent to 4, so those two. All right, with algebra, you can sort of just plug through it and just get to the answer without thinking too much. With geometry, you sort of have to have a plan before you get into it, right? Otherwise, you're going to sort of kind of go off the rails. So let's look here. We know that 1 is congruent to 4. They want us to prove that 2 is congruent to 3. Angle 2 is congruent to angle 3. Okay, first of all, do we believe that, right? Let's just make some numbers up here. Let's say that this is 80 degrees and this is 100 degrees. All right, so let's think what we could figure out here. What types of angles do we have? Well, 1 and 3 are vertical angles. So that means that 3 has to be, vertical angles are always congruent, has to be congruent or 80 degrees. Okay? Oh, I'm so dumb. I'm sorry. Let me back up here. Pretend I didn't say that. Okay. Let me back up. We're still going to use vertical angles, but I didn't use the given we started with. We are given that 1 is congruent to 4, so they have to be the same, right? So if they're the same, that means that this is congruent to this, and they make a line, so let's say they're both 90. That makes sense. They both should be 90. If they make a line, they're congruent. All right, well, if this is 90, then these 1 and 3 are vertical angles. So we could say that 3 is 90 degrees. Okay, now this is tracking more. And 4 and 2 are also vertical angles, so we could say that 2 is 90 degrees. And then, hey, look, they're both 90, so 2 and 3 have to be congruent. There, that's better. So essentially what we're going to do is we're going to say that they're vertical angles, and then we're going to substitute in at the end to get 2 and 3. So let's do that. So we know, I'm just going to write this up here. We're going to use vertical angles are congruent, and then we're going to use substitution. Because we need to substitute the 1 and the 4 in for the other angles we're looking for. All right, so let's start with our given. So angle 1 is congruent to angle 4. That's our given. Then from there, we want to name our vertical angles. So 1's vertical angle is what? It's across, it's 3. So we'd say angle 1 is congruent to angle 3. And the reason why is that vertical angles are congruent. All right, let's list the other pair of vertical angles, which would be 4 and 2. So angle 4 is congruent to angle 2. And once again, because vertical angles are congruent. All right, and now we can do a little bit of substitution. Okay, here's what I want to do. I want to take this statement here, okay? I want to take this statement here, and I want to replace each part of it, okay? So, the 1, I'm going to replace the 1 with a 3. And then after that, I'm going to replace the 4 with the 2, and I should be where I want to be. I should have a 2 and 3 in the end. So let's just replace the 1 to start with. So let's say I'm now going to say angle 3 is congruent to angle 4. And all I did was replace this 1 here with the 3 because we said they're congruent, so this will be substitution. And now I'm going to do the same thing with this 4 here. I want to change that. And I'm going to change that to a 2. So now I'm going to have angle 3 is congruent to angle 2, substitution.
Would Isaac Johnson come to the office? Isaac Johnson.
And there we go. We have our answer. The only thing is they write it in the other order, 2 then 3. So there's one step we can add. And this is where we switch them. So it's angle 2 is congruent to angle 3. And that would be the symmetric property. Symmetric means we can switch the order, doesn't matter. And I will say that this step I consider optional. I don't really care too much if you have it or not, although it is nice to make it match what you're trying to prove. All right, so that's a geometric proof. All right, let's try another one, another similar one, see how that goes. let's start with our given and make a game plan. Our given is that 2 is congruent to 5. I'm trying to prove that 4 is congruent to 8. All right, 4 and 8 are here and here. So let's look at the relationships we have with 2 and 5, okay? They both are, 2 and 4 are vertical angles, and 5 and 8 are vertical angles. So this is going to be a nearly identical proof, because once again, we're going to state vertical angles are congruent, and then all we have to do is replace the 2 and 5 like we did before with the 4 and 8. So our tools again are going to be vertical angles are congruent and substitution. All right, so let's start it. And if you want to try it on your own, pause it and try it, see how it goes. All right, so we're going to start with angle 2 is congruent to angle 5. And the reason is it's a given. And maybe we should make sense of this a little bit, right? I suppose, why not? Let's say this is 100 degrees, and that would mean they're congruent. This is 100 degrees. If they're vertical, that would mean that these also have to be 100 degrees, because vertical angles are congruent. All right, next step. We want to state our vertical angles. So let's start with 2 and 4. So angle 2 is congruent to angle 4, and that's because vertical angles are congruent. And then we're going to say 5 and 8. Angle 5 is congruent to angle 8, and that's because vertical angles are congruent. Now, some people will substitute both in at the same time. That's totally fine. I don't mind that at all. If you want to substitute the 4 and the 8 in all at once, I'm going to do it one at a time just so you can see what I'm doing. Because remember, I'm going to replace this 2 with this 4, and I'll get angle 4 there. And I get angle 4 is congruent to angle 5. And that's because of substitution. All right, I'm almost there. I just got to have 4 and 8. So I'm going to replace this 5 with this 8 here. And let me just get the right color here. And then I get angle 8 there. And that's going to be angle 4 is congruent to angle 8. Substitution again. All right, I do not need to do anything else because it's matching exactly what I'm trying to prove, and I'm done. So this is the most common type of proof with vertical angles, at least for the lesson we're doing. But there will be some different ones in the future, like this next one. We now are trying to prove that 1 and 2 are congruent, or 1 and 3 are congruent, but we're told that 1 and 2 are supplementary. So 1 and 2 are supplementary, and 2 and 3 are supplementary. So let's make up some numbers to make sense of it for ourselves. Let's say that 1 is 10 degrees. If 1 and 2 are supplementary, I mean they add to 180, what would 2 have to be? Well, it would have to be 170 degrees. Okay, and then if 2 and 3 are supplementary, 2 would have to be 10 degrees. All right, so then they want us to conclude that 1 and 3 are the same. So let's think about the tools we're going to have to use. Okay, we're obviously going to have to use the definition of supplementary, right? We need to know that supplementary means 180 degrees. So we're going to have to use definition of supplementary. What else are we going to have to do? The only other thing we'd have to do is probably some substitution to replace some of these values so we have 1 and 3. So probably just definition of substitution, or sorry, definition of supplementary and substitution. Okay, so that's sort of our game plan. So we're just going to start by stating the supplementary sides equal 180, or angles equal 180, and then we're going to go from there. All right, so let's get into it. Let's start with our givens, obviously. So let's start your givens. So angle 1 and angle 2 are supplementary. Try to fit both of these. Angle 2 and angle 3 are supplementary. And that is our given. All right, if you want to pause it here and try it, go for it. It's not a super long proof, but it is a little different from what we did. All right, so first thing, I'm going to say that 1 and 2 make 180. So I'm going to say the measure of angle 1 plus the measure of angle 2 equal 180. And that is the definition. And I'll actually write it out. Definition of supplementary. And I'm also going to say the same thing for 2 and 3. The measure of angle 2 plus the measure of angle 3 equal 180. And that's the definition of supplementary. All right, so now we have to do something a little bit tricky. Okay, so if you tried it, you're stumped. Don't feel bad. This one is a bit tricky. So what we're going to have to do is we're going to have to substitute in kind of a funny way. Okay, we know that both of these equal 180, right? So if 1 and 2 equal 180 and 2 and 3 equal 180, we can say that both of these are equal. So essentially what we're doing is we're replacing this 180 with 2 and 3 because it also is the same as 180. So it's going to look like this. We're going to end up on this side, on the right side, with measure of angle 2 and the measure of angle 3. And we substituted that in. And we're going to keep over here measure 1 plus the measure of angle 2. Okay, so now we're in an interesting spot where we substitute it in. And we have to somehow get to 1 and 3. Now look at this equation here. How could we make it so just 1 and 3 are left? Well, we have a common term on both sides. I know these are angles we're talking about, but these are measurements, right? Degrees. In the example we gave up here, 2 was 170 degrees. So we could subtract this from both sides and then it would be totally gone. And that's what we're going to do. We're going to subtract, I'll just show you what we're doing here. We're going to subtract the measure of angle 2 from both sides. And we'll just be left with the measure of angle 1 equals the measure of angle 3. And that would be the subtraction property. So sometimes you make a game plan and then once you get there, there's some other tricky things you have to do to get to your final result. Now, we have that the measures are equal, but we don't have that they're congruent. So how we can fix that is we can just say that they are congruent. So we can say angle 1 is congruent to angle 3, and if you remember, there is a reason why we can say that, right? We're making equal a congruence, so we can say the definition of congruent. Definition of congruent. There you go, and your proof is done. Put a star by it, and a happy face. You did it. Okay, I think that's it. Yeah, good job on the notes, and I will see you next time. Bye-bye.